This is number 13 from the review package, the energy section, and it's Tarzan. And he's on a vine. And he's going to swing down. He starts 15 meters above the ground. And he's going to swing down to a branch that's 4 meters above the ground. And the question is, how fast is he going when he hits that second branch? And we know his mass is 85 kilograms. There are really two ways to solve this question. You could do it with kinematics, but it would be pretty painful. You'd have to do a lot of trig, and because gravity is pulling him straight down, but then his motion changes, so he has this force of tension, and you have to work that out with centripetal motion and everything. You could do that in Physics 12, but we're not going to do it this year. We're going to use something else. How else are we going to solve this? Good, energy. So we're going to start off with MGH, or EP, and that's going to turn into what? Kinetic. Now, does he still have potential energy on the second branch?
Yes.
Yeah. So there's two ways of solving this. You can say, well, he has a little bit of EP still, and he gains some EK. And so you can say, well, his original potential energy is equal to his second potential energy and the kinetic he has here. Or you can say, well, I'm just going to make this height 0. And so if this is the 0 point, and I say he's 11 meters above the 0, then you can just say, well, all the potential will translate into kinetic. Which way would you like to do it?
That way.
That way? Okay, let's do both ways. Let's do both ways. So we'll do the, let's do reset 0. And 0 is 0 over here. Or ground, I could say ground is 0, I guess. So if you use this way, you're going to take your original height at 15. So you're going to say, you're going to find EP. And so that's MGH. So he's 85 times 9.8 times 15. And you get on your calculator. There you go. So we started off with 12,495 joules. That is the total energy. We're never going to get more than that. There's no friction here, so none of it's going to get used up either. People are going to think I put background music in my video. Very dramatic. Tarzan swinging. This is going to split into what two types of energy? Kinetic and potential. He's still going to have some potential left. So let's find his EP down at the branch here. It's still MGH. And so he's 85 kilos times 9.8 times now. He's only 4 meters off the ground, so do the 4 here. Let's find out what that is. I got 3332. So he still has this many joules of potential left. Over here, that means what's left must have been turned into kinetic. There's no heat. Okay. So if I take my original potential energy, which is the total, and subtract the potential energy I have at the bottom, I should get my EK. And if I do that, I get 9163 joules. If you're good with the calculator, you're just you just leave the number in there and you just go minus this, and the answer will be negative, but you know it's positive. Okay, that's your EK, so now we just have to solve for a velocity, right? So you say 9163 equals half mv squared. So we multiply both sides by 2. 2 times 9163 divided by the mass, which is 85. And we're going to have to square root it. That's going to be my VF, and that is times 2 divided by 85 equals square root. The answer 14.7 I got. You agree? Did I make any mistakes?
No, that's correct.
Okay. Let's do it the reset 0 way and just see if it's quicker. If I reset 0, then the original height is now not 15. What is it? 11. Because if I take this as being 0.0, then he's really 11 meters above the branch. Okay? So you got to remember that. In that case, all of his potential is translating into kinetic. So if I do that, I say mgh equals half mv squared. And mathy people, what am I going to do with this? Good, Yazzie. We're going to cross out these masses. They're gone. And we don't even need to know how heavy he is. And if I solve this, I'm going to put the 2 over to this side, and I'm going to square root it to get rid of that. Square, and that's going to equal my mass. That's all I have to do. So I do 2 times 9.8 times my height, which is now 11, and I square root that answer, and I get 14.7. Kind of easy one, I would say, right? But either way works. But either way works. Now here's a question. If he were to pick up Jane here, and Jane has a mass of, I don't know, how much does Jane weigh? Jane is the lady, right?
Yeah.
Jane?
Yeah.
The question is, if he picks up Jane and Jane is, let's say 50 kilograms. How high will they go at the top of their swing? To the heavens.
I think that like 0.5.
Do you know how to do it? If they swing right to the bottom, then come back up. If he's up here, and he's 85, and this is a 20-meter vine, and he swings all the way, but down here he picks up Jane, and they go back up. How high is this? Will they go as high? Will it be the same height?
No.
No.
Like the pendulum.
Great. So their mass here together is going to be 85 plus 50, right? What is that, 135?
Yeah.
Yes. Taylor, good. Is this EP going to be different than this EP?
Yeah, that's so much better.
How?
Well, aren't they still swinging?
Well, up
Like,
here
are they in mid-swing?
they're gonna be stopped, right?
Oh my god.
Oh, they bring him like another.
Yeah, he comes down and picks her up and they swing back up. Ainsley,
What I do.
say that again. Oh yeah, yeah, you're right. He's gonna hit the. Oh yeah, so they both die and the problem's over. They're on the ground.
Problem solved.
Yeah, that's pretty smart actually.
They
Yeah.
don't get to that height.
Let's say they could swing all the way through. How would you find out how high they got? Yes.
When you find out the potential energy at the beginning, I go through their masses and then that's the same.
So MGH at the beginning, so M1GH1 would equal this potential energy over here, yes?
Yes.
These two potential energies will be the same. You don't need to know the velocity or anything about the bottom. But Ainsley makes a good point. You do have to make sure they can swing through. So otherwise they're gonna hit the ground. Do you need to put G in? Mathy people? What can I do with G? Cross it out. So this is true on any planet. It'll be the same. But the masses do change, so we can't cross out the masses. So if I want to solve for this, I'm going to go M1H1 over M2. And that'll give me my second height. This is M1G1H1, and over here is M2GH2. So I'm going to do 85 times. I guess you'd have to make the original height 20, because the vine is 20 long. You couldn't do it 15. So you'd have to say 20 over 135. What does that equal? 13, 12.6. Makes pretty good sense.
Wait, did you change his mass?
No. Well, yeah, because he picks up Jane.
How come the height's 20?
Because the vine is 20, so at the bottom they're going to be 20 meters down. It doesn't really matter what height you use, but it has to be bigger than 20. Otherwise they'll hit the ground and die, as Nancy says. That's that. Would that work in the real world, by the way? You're gonna lose some heat in the collision, right? So it's not gonna be perfect. But in physics 11 it will be.